Hi, my name is John and I'm a Unity developer. Today I'm going to be giving an update on the inverse kinematic solver that I've been building. So the idea in inverse kinematics is that we have a limb, in this case composed of these cylindrical segments, and so segment 1, 2, and 3, and then you specify targets for the inverse kinematic solver to figure out how to orient that limb in order to touch. So for example, I've specified that all of these 8 limbs here should try to touch one of these targets in target squares here. So, and they're going to interpolate between touching the various squares as they move in world space. So that's what it looks like. And again, alternatively, instead of orienting to touch targets in world space, we can just set them to display an interpolation between their targets at any instant. Okay, so let's look at the real-time on-the-fly solving again. That's what it looks like. Okay, and now let's look at the properties of this solver in more detail. So, for example, this is another limb which has been told to solve for a sequence of touches here, here, and then there. And there's a purple debug line which is indicating the maximum extent of the limb. So in this case, the limb at full extension is still unable to touch this target. So there's a vector which is colored in red, which extends from the root to the target, and then there's also a vector in blue, which represents the maximum extent of the limb at its completion of the rotation. In this case, it's simply impossible for the limb to turn up that way because of certain constraints that I've put on the limb. So that's why we were able to see the rotation from, we were able to see the vector from the origin to the full extension of the limb. So we're able to see that here, the limb is able to solve in real time in order to touch the sequence of cubes. Okay, and then here we have a target. Well, we have 2 limbs here. So this limb, these 3 are trying to touch the point right here, which is pinned to another limb, which has and that limb itself has a target, which is this orange cube, or this cube highlighted in orange. So when I move this orange cube, it's going to move the position of this point here, which is going to change the solution for this limb here. Let's look at that. So that's what it looks like. And of course, another property of this inverse kinematic solver is that it tries as hard as possible in order to interpolate between its current orientation and the one that is necessary in order to solve for their target. Okay, so the code should be publicly visible at github.com/JohnASharifi, and it's certainly not ready for use in production yet, but I'm hoping that if I share it with others that we'll be able to make progress on it.